Museum Society. I'm talking to you here in the classroom at the Okanagan Heritage Museum in downtown Kelowna. And today, we're going to talk about dinosaurs. So I have a special guest here, a couple I guess. One is Roxy, or is it Rex? Not sure. Is it a he or a she? Hard to tell without a little bit of closer investigation. But never mind. You may think that Rex or Roxy looks familiar. And if so, you could be right because this dinosaur is a movie star. Have you seen the movie Night at the Museum? Remember the dinosaur? This fossil was collected in Montana in the Hell Creek area by scientists from the American Museum of Natural History. That's the museum where the movie takes place. And the fossils actually are part of the collection there. And copies or casts from that dinosaur, from those fossils, have been shared with museums around the world. And we're so excited that we have one right here at the museum in Kelowna. It's got a friend too. So you may be wondering, did Tyrannosaurus Rex or Triceratops, did these particular animals, these ones right here, the ones that we have right here in the museum, did they live in the Okanagan? No. Did dinosaurs live in the Okanagan? Probably. Maybe. Am I sure? Can I prove it? Well, no, I can't prove it. Why not? Because I don't have fossil evidence. Let me explain a little bit more. And I'm going to start by talking about geologic time and how fossils are formed. And that'll help us understand that apparent paradox. So, I have here a useful piece of string like this. And with this string, we're going to think about geologic time. Now, this string is exactly 543 millimeters long, 1 millimeter for every million years. And that's the period in time that paleontologists describe as the age of abundant life, because most of the fossils we've ever found are from this period of time. Now, I'm going to divide it a little further. The first era I'm going to talk about is the Paleozoic. See, it's the biggest one. Paleo means old, zoic means life, ancient life. So this is the period of time that went on for millions and millions of years before the dinosaurs emerged on the planet. The second period of time, a little bit shorter, is called the Mesozoic. The Mesozoic is sometimes called the age of dinosaurs. It went on for a really long time, not as long as the Paleozoic, but a really long time. And so all of the fossils that have ever been found of dinosaurs are from this period. And in fact, dinosaurs from this era, technically speaking, have been found on every continent on the planet. They were everywhere. They were probably here too. Why wouldn't they be? It's a pretty good place. This last era is called the Cenozoic. The Cenozoic started 63 million years ago when the dinosaurs went extinct, the end of the Mesozoic, and continues today. We're living in the Cenozoic. It's not as long as the other eras, or at least not yet. But here's something that I think is very, very interesting. I hope you do too. Age of dinosaurs was so long that the dinosaurs at the very end of the Mesozoic, like these guys, like Tyrannosaurus Rex, and like Triceratops, that were some of the last dinosaurs, they live closer in time to you and me than to the first dinosaurs. What does that mean? The probability of Tyrannosaurus Rex walking down the trail and seeing a Stegosaurus, one of the earlier dinosaurs, is less likely than us walking down the street and seeing a Tyrannosaurus Rex. because we live closer in time to this buddy here than he did to the early dinosaurs. I think that's amazing, and it just shows you how long dinosaurs roamed around the planet, stomping and snorting, kind of controlling the whole thing, and how insignificant sometimes I feel when I think about time in comparison. We can't prove that dinosaurs lived in the Okanagan unless we can find fossils from that period that provide the hard evidence. Well, why can't we? Well, it all comes down to how fossils are formed and the three kinds of rocks. Do you remember the three kinds of rocks? You probably learned about them at some point. Igneous, metamorphic, sedimentary. Look it up if you don't remember. Sedimentary rocks is the kind of rocks where fossils are found. So in order to find dinosaurs, we need sedimentary rocks from the age of dinosaurs. We don't have that kind of rock in the Okanagan. But let me show you how that works. I think it'll make more sense. Okay, so how do fossils get formed? Well, here's my friend the Parasaurolophus. Let's imagine that Parasaurolophus has taken a walk, let's say 70 million years ago, across some damp sand next to a big ancient river. You can see that there is a trace of where this dinosaur has gone. Footprints. So footprints can be preserved as trace fossils. So if this whole layer of sand with the footprints is somehow preserved pristine for thousands of years and has a chance to turn to stone, sandstone, doesn't happen very often, but when it does, you can end up with fossil footprints, like this one here. This one's from an Allosaurus. I love trace fossils, because trace fossils are records of the activity of the animal while the animal was alive. They can be footprints, burrows, nests. For example, we have a dinosaur nest from Mongolia, from the oviraptor dinosaur. That's a record of the activity of the mother dinosaur who created that nest and laid those eggs. That happened while that parent dinosaur was alive. Other kinds of trace fossils, this is one of my favorite. What do you suppose that is? Kind of looks like, well, yeah? Is it squishy? No. Does it smell? No. But you got it right. It's poo. Dinosaur poo, we think. We call dinosaur poo, or any fossil poo, coprolites. And they are super exciting, yeah, because like footprints, they're a record of the animal's activity while it was alive. Whereas fossil bones are records of the animal after they died, which is cool, but it's a different kind of cool. So how are petrified bones formed? How do we get that kind of fossil? Well, let's run this scenario again with Parasaurolophus, but this time things don't go so well. So our friend, the Parasaurolophus duck-billed dinosaurs walking, same walk, but this time, whoa, we're not feeling so good. Feeling a little not great. Oh my gosh, what is that? Kaboom! Keels over dead. Terrible, terrible day for this little creature. And amazingly, shortly after the dinosaur falls down dead and before the body and the bones have had a chance to decompose or rot, which is what usually happens when an animal dies, the river floods. Imagine the river flooding and carrying layers of sand and mud, goes right over this animal, and when the flood stops, it leaves a layer of mud. Like that. Now, that kind of sediment covers the fossil bones in this case. Now, imagine for thousands of years, this little part of the river is left undisturbed. And the sand turns to sandstone. The mud turns to mudstone. Those are two kinds of sedimentary rock. And trapped inside are the remains of this dead duck-billed dinosaur. So, given enough time, those bones will turn to stone, they'll turn to rock, like this one, or petrify. Petra means rock, petrified means turn to rock. This is a vertebra or backbone from a duck-billed dinosaur. So, pretty amazing. I love this fossil, even though it's from a dead dinosaur. So, wait a minute, how do I see the dinosaur? He's buried in rock. Well, there's something else we need in order to find fossils. We need erosion, we need weathering, we need the wind and the water to work away on the layers of rock. So, sort of like a knife, the rain comes down and it washes away a little bit more sediment every year. And this goes on for thousands of years, maybe millions of years, a little bit every year. And given enough time and given proper placement, oh, there we go. At some point, the forces of erosion may start to uncover bits of our dinosaur. Maybe it's just a toe, maybe it's just a foot, maybe it's a little more. But as soon as that little bit of bone is exposed to the forces of weathering and erosion, it's going to start to crumble too. And that's why when we find dinosaurs, usually we don't find a skeleton lying on the ground looking like he just keeled over. What we find is this: little pieces of dinosaur rubble, broken bones, little bits that have weathered off the skeleton and washed down the hill. So, how do paleontologists find this stuff? Well, first of all, I want to tell you, sedimentary rock is the kind of rock that we find fossils in. And like I said, if we had sedimentary rock from the age of dinosaurs exposed in the Okanagan, maybe we would find dinosaurs. But we don't, or at least if it shows up somewhere, we haven't found it yet. But we do have a different kind of sedimentary rock. We have sedimentary rock from the Cenozoic era, after the age of dinosaurs. Dinosaurs are extinct, geology goes on, life goes on, and here in some places in the Okanagan, you might find sedimentary rock like this with pieces of needles from a redwood tree. Might even see little bits of seeds and twigs in there. You can even see a little bit of a broadleaf right here. The forest floor. Imagine a forest kind of like what you might see in China or in Northern California, growing here in the Okanagan. So we can find fossils, amazing fossils with amazing stories to tell, just not from the days of dinosaurs in the Okanagan. Okay, so now I'm a paleontologist. I'm not really, but let's pretend I am. Well, how would I find dinosaurs, and then what would I do? So, first of all, I'm going to tell you a little bit about myself. I spent a quarter century in the dinosaur capital of Canada, the Badlands of Alberta. So, paleontologists are scientists who study ancient life by looking at fossils. I'm not one of those, but I spent a lot of time working around paleontologists, working with paleontologists, doing some paleontology, and most of all, sharing the wonder of paleontology with thousands and thousands and thousands of people during that period, sometimes through science camps, and sometimes through educational dig programs where we got to dig dinosaurs together. And here's some things I learned during those years. So, first of all, this is a really, really important one. This is like one of the most important things I'm going to teach you today. It's called the paleontology position. And it goes like this. You ready? Okay. Why is the paleontology position important? Because even though we may be looking for creatures of a pretty good size, to find them, we actually need to find the little broken bits of dinosaur rubble, like this. just looks like a rock. It's not very big, and you have to be very observant and look very closely and be very curious in order to find them. And you have to persevere. And let me tell you, that can mean a lot of hiking around in some very rugged and challenging conditions. So we're looking for the dinosaur rubble, and when we find it, maybe we can follow the pieces of dinosaur rubble up the hill, and if we're really, really, really lucky, maybe we'll find that dinosaur skeleton poking out of the rock, just like my duckbill that's sticking out of the Play-Doh. If we do, what next? Well, let's say I'm a paleontologist and I want to collect that dinosaur for my museum. Well, the first thing I gotta do is get a permit, because even if I'm an expert and I have excavated 100 dinosaurs before, this one, every dinosaur is unique and special and fragile and irreplaceable. There has to be a good reason to collect it, and it has to be done properly. And so a permit shows the respect and the care that paleontologists spend doing their work. So here I have, and then I can start to dig in an excavation, maybe a dinosaur quarry. So here I've recreated a little quadrant in a dinosaur quarry, and I've got real dinosaur bones embedded in a kind of sandstone from the Badlands. So I've got a small hammer, a pick, and a brush. And this is what I'm going to do. I'm going to very, very carefully uncover the entire length of each bone. And in order to do that, I have to keep my work very, very clean. I have to work slowly, I have to be patient, and have perseverance, and be really observant. Do I ever get impatient and want to go kabam, 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 get that dinosaur bone out of there? Yeah, especially at the end of a really long, hot day. I'm thirsty, I'm tired, I want to go back. But you don't get to do that when you're dealing with precious resources like an ancient fossil. So patience, go slow. When we've completed our excavation, then we will take plaster-filled jackets, kind of like burlap dipped in plaster of Paris, and we'll wrap them over each bone, let it dry, remove them from the rock, and haul them out of the quarry and to the museum. That's hard work. But then the real hard part starts. It may take one summer to excavate a dinosaur. It may take a decade to prepare it for display and study, because every little fossil needs to be cleaned and pieced together carefully. So remember, they're pretty old, they're pretty crumbly, and they're probably broken. So one of the things we have to do is put the broken bones together. It's like a puzzle. And so if you look into the lab, the preparation lab at a dinosaur museum or a paleontology museum, you'll see scientists working around big sandboxes. Is it because they like playing in sandboxes? Yeah, they like playing in the dirt. They like sand, but the sand also helps because it positions each chunk of broken fossil just right, so that you can get the levels just right. And let's see if I can make this one go together. I've got this last piece. How does it go? It's got some shininess here, which looks like the shiny piece here and here. That's the outer cortex of the bone. So I'm gonna guess it's gonna go right here. Oh, not quite. That's not quite right. There we go. Okay, that's better. So a chunk of this dinosaur leg is now put together, and the other pieces need to be added on with time. So once I have found, excavated, prepared, and assembled the fossil bones, then the next thing we need to do is make a cast or a scientific copy of the fossil. Like these guys, because the fossils are so ancient and crumbly and broken, and not only that, they're heavy. And so making an exact replica, a copy, means we can put dinosaurs in full form on display in galleries of museums around the world. If we didn't do that, most of us would never get to see dinosaurs when we went to the museum. So these scientific copies are pretty important. And besides that, that's the way that the American Museum of Natural History can have the same Tyrannosaurus Rex as Cologne Museum Society can. I think that's pretty special. So paleontologists need to have a lot of qualities: curiosity, patience, perseverance, respect, and paleontologists have to be very, very observant, right? Yeah. So some of you may be thinking, hey, maybe I'd like to be a paleontologist. I'd like to be one of those scientists who studies ancient life and finds fossils and looks at them and learns about them. Well, let me tell you, you can start by watching dinosaurs in real life. Now, okay, so here's the thing. I've been lying to you just a little bit. I've been telling you throughout that dinosaurs have not been found in the Okanagan. What I was really talking about was dinosaurs from the Mesozoic, the age of dinosaurs. But guess what? They're still here. Yeah, they are. So, how do you see them? Maybe put a dish of water in your yard and you can watch dinosaurs splash around. Maybe put a useful piece of string on a branch and maybe a dinosaur will make a nest out of it. Or maybe you can take a walk in the park and you can listen to dinosaurs singing all around you. Yeah. You got it figured out, don't you? I'm talking about birds. Birds are dinosaurs. Yes, they are. Little feathered dinosaurs. You don't believe me? Look it up. But it's true. But the qualities that it takes to study birds, living dinosaurs, or anything else, frogs, rocks, lichens, electromagnetic waves, stars, planets, how machines work. Scientists who study all of those things are driven by curiosity. And along with that, they have to develop the qualities of patience, perseverance, respect, and observation, right? So what I hope is that you develop those qualities. You may be interested in all those things and may not know it yet. So I hope to see you out exploring the world. One way that you can explore Okanagan is with us at the museum. We hope that you follow us online, where we have lots of interesting videos and posts about Okanagan human and natural history. And we hope someday to see you here at the museum. Thanks. I think I'll go look for some dinosaurs.